Hello guys, welcome back again. We're glad to have you back to the channel. Here we'll have another function y to be equal to bracket open x to the power 5 minus x to the power 2 plus 1 all bracket close to power minus 3 over 2 to find the derivative, to find the dy dx of the function. This type of function here is a composite function. So we're going to use what we explained in our last video, the chain rule, to split it up into a function of a function. You're going to take the value of x to the power 5 minus x to the power 2 plus 1 here to be equal to u. So we'll let u be equal to x to the power 5 minus x to the power 2 plus 1. In that case, y will now be equal to, the whole of here is u, y will now be equal to u raised to the power minus 3 over 2. So we have chained x to u and we have chained u to y. That's the chain rule. X is a function of u now, u is a function of y. So we also call that aka the function of a function or the chain rule. So we're going to find the derivative of u with respect to x and the derivative of y with respect to u. Here, du dx is equal to 5x to power what? 4. 5 minus 1 minus 2x, right? 2 minus 1 here is going to give you x. Then the derivative of a constant here is 0. So we are done with the derivative. Come to this other side, we'll have dy du. That will give us minus 3u over 2 raised to the power minus 5 over 2. How do we get this? I'll quickly just talk about that. We know how we differentiate that. But because it looks a bit complex, I will just talk about it at the bottom here. Okay, we'll have minus 3 over 2 minus 1 over 1 from derivative. The LCM here is 2. 2 into 2 will give you 1 times minus 3 give you minus 3. 1 into 2 will give you 2 times minus 1 will give you minus 2. Minus 2 minus 3 will give you minus 5. That we'll have here. Okay. Quickly, we take this off from here. And we'll also take this off from here. That's not part of it. What we'll have there is just minus 5. Minus 5 over 2. So from there, going ahead, so we'll now have the u dx to be this, and we'll have dy du to be this. So we're going to put this in our function by chaining dy dx. Now finally will be equal to dy du, as we explained in our last video, multiplied by what? Du dx, the chain rule. This is the chain rule. So we're going to substitute dy du here to replace dy du here, and substitute du dx here to replace du dx. Let's do the substitution. So dy dx is equal to dy du, which is minus 3u raised to the power minus 5 over 2 divided by 2 times du dx, which is what? 5x raised to the power 4 minus 2x. Okay, simplifying further, we'll have the power here is negative. We can bring it down, take the reciprocal of u, so that power become positive. We're left with 3 at the top, multiplying the derivative of what? Du dx, 5x to the power 4 minus 2x all over 2 is left at the denominator, multiplying u to the power 5 over 2. At this point, we have to bring the value of u. You recall from our opening question, that u is equal to s to the power 5 minus s to the power 2 plus 1. So we'll bring that value to replace u. So we'll now have minus 3 brackets 5s to the power 4 minus 2x at the top divided by 2 brackets x to the power 5 minus s to the power 2 plus 1 raised to the power 5 over 2. You can actually do that to take the fifth root if you want to. If you don't see this as an option, it is a multiple choice question. You can go ahead and do it further like this by keeping this as minus 3 bracket 5x to the power 4 minus 2x divided by 2. This square root of s to the power 5 minus x to power 2 plus 1 all in brackets to power 5.